Hello, so we are back Tuesday and it's a beautiful day outside. What do we have today? We have a gaming laptop. Okay, this is a ROG laptop, Ryzen 7 and Nvidia graphics, ROG Zephyrus. Okay, the gaming laptops, they are expensive. So we are trying to figure out the fault, or we are just give them more time compared with the normal laptops, just because they're more expensive. The first things what we ask the customer, especially when it's a gaming laptop, if they open the laptop already, because many times you'll have, let's say if it's a water damage spot inside, and the customer open the laptop and he see the spot, he'll clean the spot. Hopefully, he's thinking it will work. And if we are not seeing that spot, we are missing the fault. So it's kind of obvious. And on this case, the customer said he opened the laptop, but he didn't do anything inside. Okay? So let's open this and fix. Or first, let's check. Yeah, let me grab the charger. I know it's dead. It's just a dead laptop. I booked in the job yesterday, and the customer said, "Oh, I know you. I saw you on YouTube." That's make me feel bad, In a case you fix the laptop, everyone is happy. When you don't fix it, it make me feel bad. Plug in the charger and we have no light, nothing. Pressing the power button, nothing happened. It's just dead. Okay? So let's open this. The model of the laptop is GA502D. Okay? Let's try and fix it. You know what I seen randomly browsing YouTube? I seen last week a live stream from Apple. They were launching the new iPad, and I was impressed. So on the iPad Pro, they said new iPad Pro, the big one, they achieve 1000 nits brightness and HDR, high dynamic range. Now, to achieve something like that on it's a LCD screen, LED screen, it's hard, and I was impressed how they figured it out. So basically on any LCD or LED screen, you have the backlight, LEDs or whatever on a side, and you have a diffuser behind of the screen. So they remove the diffuser and they fit another screen behind of the screen, which is also connected to the graphics. So it's a screen made with LEDs behind of actually screen, and that's how they achieve HDR and 1000 nits brightness, which I was impressed. If you are looking online, if you are looking online to buy a monitor, let's say you have a camera, Like I have the Black Magic and I'm looking for an external monitor, and I was looking for an external monitor. If you're looking to buy high brightness external screen like 7-inch, they are very expensive. They can go easily over £1,000. So I was impressed by the Apple. I'm not Apple fanboy, but you know, I love the technology. Okay, those two screws are not working. Let's see what we can do. The screw is flexing. Okay, so the customer fit the wrong screws on the holes. We'll see after that. Wow, look at that. See, that's a proper gaming laptop. Nice design. So check here, yeah? You have a heat pipe from the processor and graphics to the both fans. You have graphics memory pipe, which is going here. And you have the second pipe from the graphics and processor, which is going on this side of the fan. Proper nice design. Proper nice design. Look at those speakers. Big speakers. That's a nice laptop. Okay, so let's plug the charger and see what's going on. What do we check first? So plug in the charger. Here. What do we check first? First, we check 19 volts. First on the charging port, and then following the 19 volts power rail. So ground, you can get ground from anywhere, and we have the charging port, and we have nothing. The charger is plugged. Let's check the charger. And I have nothing. So the charger is gone? Come on, that would be awkward. It's a big charger. 20 volts. Check on the multimeter on the screen. 20 volts. Okay, this can be another issue. If we plug the charger and the voltage goes down. So we have 20 volts. Let's plug the charger. Well, let's check the voltage now. And we have nothing. So basically we have nothing. You know why? Because the chargers, they have a protection. In a case of short circuit, they will cut down the power. So if the board is shorted, let's come with the power supply on the same point, yeah, on the charging port. I shall not take that out with the battery inside, but by mistake I took it out. So let's see. Power supply 20 volts, around 1 amp, minus plus, and we have a short. So the limit is 1.6 amps, the voltage 2.4. That means the short is not here. And then we have two MOSFETs next to the charging port. So I really have hope for this laptop to be fixed, because usually a shorted board is more easy to fix compared with another board. Let's say you have another board, the voltage is right but it's not starting, which is most likely a super IO issue. I prefer a shorted one. And what happened with my microscope? Yeah, it's on. So you have the charging port. Okay, just follow the route, yeah. So check there. You can see on this case the ground is separated from this track. So the plus is soldered here on this track, the big track, which is plus. It's coming to the first MOSFET. Then you have the second MOSFET is going to the second MOSFET, and from the second MOSFET, yeah, from the second MOSFET you have that current resistor, and from here you have your main 90 volts power rail. This one should be 19. Okay, pretty easy and most common design. You'll find this design in 99% of the laptop, 99.9. Even the Apple laptops, they have same input design. Okay, there are few laptops, low power laptops, usually small laptops, they replace the first MOSFET with a diode, but you still have the second MOSFET. The purpose of those MOSFETs are just for protection. Yeah? They cut the power down in case something happens, but not on this case. Like how you can see, the board is shorted, but the MOSFET are doing nothing. So one more time, let's go with the power supply, 20 volts. So on this case, we know already it is a short. You can see there 1.6 amps. Is going the limit, and the voltage goes down to 2.4. So actually the voltage here is a reflection of the resistance. Okay, checking here we have the volt 2.3 volts, and checking on the output we have 1.6 volts, which is very bad. And checking after the first, yeah, that's bad, you know. Let me explain you why. Yeah, give me 1 second. You know, I will proper explain you why. Give me 1 second. Okay. I can explain you why. Because playing with the power supply can be easily, but at the same time you have to learn to read the results. And the results are bad comparing with the other cases. You remember we made so many, you know, shorted capacitor on the main power rail. Do you think here it's a shorted capacitor? A very low probability. Let me take down my jacket. It's getting hot here. Okay, and you'll think, sorry, but it's a short there, so obviously it must be a capacitor. Well, it's not short. Short has so many meanings. So let's say, again, yeah, you have the input circuit, you have the charging port, okay, then you have plus and minus. Minus is ground, so just ignore the minus, just focus on plus. Plus is going, let's say, in the first MOSFET. You don't really need to know what kind of, just see that MOSFET, first two MOSFET, I want to see them like a switch, nothing else, okay? I have a switch, the symbol of the switch, and you have the second MOSFET. That's how I want to see them, because it's more easy to understand, because they function like a switch. Yeah, they are not fast switching. They are just switches, electronic switches. If you can take out the Mosfet, so you can feed relays, and it'll be same thing. They will do same thing. And after that, we have that current sensor, a resistor, which is this, and usually from here is going to your power management chip. Yeah, and here you have your main 19 volts power rail. Okay, so on this case you have your main power rail. From here the laptop is taking power, so you have a lot of power supplies. I'll give you a few examples. And also you have a lot of capacitors. So here you'll find probably around, let's say, 20-30 capacitors like this. Yeah, connected to the power rail, and also connected straight to the other power supplies. Yeah, like you have like 3.3 volts, you have 5 volts, you have one was DDR4 is 2.4 volts, I think. Yeah, the processor. You have a lot of power supplies. In many cases, in most of the cases, you have one of these capacitor which is shorted to the ground. Short meaning on this point you'll have 0 ohms. Checking with the multimeter, let's check ohms, ground, and we're checking on this point. Yeah, here. And we have 0.8 ohms, and you'll think it's a short. Checking with the power supply, it's a little bit different story. If you put this and you calculate, it's a different story what you see from the multimeter, and actually the resistance, which you can calculate it by the current, the voltage, and you can calculate the resistance. So the voltage here is 1.6. Okay, 1.6 volts with 1 point something amps. The resistance is quite high, so the probability to have a shorted capacitor is very low. Usually a short, meaning this, that's a short, and you can see on the power supply I have like 0.2 volts. That's a short. Yeah, this is not a short, this is a resistance. Yeah, well, why is bad? I will explain why it's bad. Let's say you have a power supply. How is a power supply? 99.9% of the power supplies, you have one Mosfet, you have the second Mosfet, have the connection, you have the ground here, and from here you have your coil, and then you have a capacitor, and this is supplying power to something. Okay, and those Mosfet, they have a driver, but just ignore the fact. Yeah, let's say this Mosfet is shorted. Yeah, just let's think this Mosfet is shorted. What will happen? Your power rail, which let's say it's RAM one, yeah, 2.4 volts is DDR4 if I'm not wrong. If this Mosfet is shorted and you do a trick like me, you're applying 19 volts, because I came with the 19 volts power supply here. You're applying 19 volts exactly on your because this is shorted, remember? So let's say you have a shorted Mosfet. So you come with 19 volts on a point where it's supposed to be 2.4. That's kind of, you killed something. Now the trick is to use a current limit. Like on my case, I'm using a current limit, like 1 amps and something. That's not. It is important to work with low currents. So in a case you have something like that, you have a limit. With 1 point something amps, you can't really burn anything. Let's say this power supply is actually the processor one, or is the graphics one. or you can't burn them with 1 point something amps. Okay, but I don't think it's the RAM one. Let's say if this is the RAM power supply, and there should be 2.4, I should have here, if this is shorted, I should have here over 3 volts, and I don't have 3 volts. I have 1 point something. So most likely, yeah, you can have, let's say you can have a shorted capacitor which is shorted and has a high resistance, but on this case the probability is very low. Actually, the probability to this power supply to be from the processor or the graphics is very high based on the voltage reading. So yeah, that's the trick. Okay, so again, let's get the power supply. Now it will be very helpful to have a thermal camera. We don't have a thermal camera, but let's open this. We need access here. You see, even the coils. Look, these are the processor stages behind of the heatsink, and here the graphics. Very nice design. Very nice design. Let's try to take them out. That's why I always told you, you know what, use a current limit. When you use a current limit, this has a seal here. And the seal is intact, so that means no one opened this before. Using a current limit, it will give you some leverage, so you can play a little bit and be protected at the same time. What do we have? We have the fans. The battery, sorry, let's unplug the battery. Forgot about the battery, but it's shorted anyway, so we have no voltage on the laptop. Okay. We have the Wi-Fi antenna. Let's unplug the Wi-Fi antenna. And we have a screw behind of the hinge. I always read the comments on the channel. I can't answer on the. You see, when you look on the video, you see the comments on that video, but there are like over 500 videos, and the people are still leaving comment on the old videos. So it's kind of tricky to read all the comments, but I'm trying. And yeah, a lot of people they said, okay, I'm learning, and I'm happy with how you explain. So it's looking complicated, but actually it's not that complicated, because I would say everyone can fix anything related with the power but not with a digital thing. You can't touch there. It's software and hardware together. Even the manufacturer can't fix, let's say, a broken track between the RAM memory and the processor, or miscommunication between the chipset and the graphics or the it's you can fix power related problems, but that's all. Okay, let's unplug the fan. Okay, look at the processor. But the processor, a small processor and a big graphic chip. Possible we found a problem. Because I was looking and I said, well, what's that shiny thing there? Probably you can't see it. Possible the fault to be here. What's that there? That doesn't look normal. What do you think? So, or maybe it looks normal. I don't know, looks some flux there. Looks like it's some flux there. But anyway, that's not the way how you find a fault. Or maybe that's the way. Okay, the visual. Okay, I understand that. But let's ignore that fact. That Mosfet can be good. Let's come with the power and try to find out. Actually, it's a bad idea to come with the power. If you have that high side Mosfet, the Mosfet connected to the 19 volts, if you have that one shorted, you come with the power, what do you think will get hot? The processor. But this is a nice laptop. Look how many stages are here. You have 5, 9. 9 phases for the processor and 2 for the graphics. This is a nice laptop. How do you find a fault on this case? You can remove the MOSFETs each at a time and see when the shortest disappear. Or let's try and come with some current, yeah? Because that processor can handle few amps. We can't really burn the processor so easily. Plus here 1.6 amps. I'm just curious if the processor is getting warm or hot, or any of those MOSFETs. No, actually the graphics. So I can feel the graphic chip warm. Really? It's the graphics. It's not the processor, it's the graphics. Let me get this. Let's try to figure it out. Let's get a multimeter. Ohms. Now let's check the graphics resistance and the processor. And we have like 4.2 ohms on the processor, and that can be normal. Many people are tricked believing it's a short, but it's not. That's the internal resistance of the processor, and that seems to be right. And the graphics, well, let me check here on these coils. And it has 0.8 ohms, which I don't believe is right. What about here? 32 ohms, which is fine. 32 ohms, which is fine. So those power supplies are for the graphics, clearly. But they are fine. Means those are for processor, 4-phase, and probably those are for graphics. Okay? So the output of the coil, or you can check on the capacitor, is like 0.4, 0.8, which is kind of low. Now this is compared with the ground. Let's compare with the plus. Yes, I'll take this out and I'll compare with the plus. You know that current resistor, which is our main 90 volts power rail? And with the plus, it's like 0.3 ohms. So yeah, we have a high side Mosfet burned. Most likely the one which we see in here. Well, let's remove this, because this looks dodgy. So everyone else looks fine, but not this one. This looks like some flux there, or something. Looks dodgy to me. So let's remove that Mosfet and see if the short is still there. Okay, so we remove the Mosfet. Wow. This is bad. This is a dual Mosfet. And I don't have something like that. Okay, let's see. So we remove the Mosfet. Let's see if the short is not there anymore. We can check with multimeter or power supply, same thing. Let's check with the multimeter. And it's nothing, like 47 kilo ohms. So if I come with 19 volts, let's come with 19. Nothing. It's taking no power. You can see. So that one was shorted. But the issue here, this is a dual Mosfet. So inside of this, you have two Mosfets. So just things on my schematic. This one, the both Mosfets are on the same capsule. Okay, that's why it's a dual Mosfet. We have to find one, because otherwise we can't fix it. We have to find a dual Mosfet somewhere. What about Apple? What they are using? We can find a dual Mosfet here. So we have one gate there. And that's all. One gate and one gate. You think ROG laptop it will work with Apple Mosfet? Let me check to be sure it's a dual Mosfet. Yeah, it is a dual Mosfet. A dual Mosfet has two gates, yeah? So we have a dual Mosfet. Just a bit of flux. It's perfect. Let's see if the ROG laptop it will work with Apple technology. Let's see what we have there. Should be fine. Let's solder this thing back. Come on. Let me grab some flux. Okay, seems to be fine. How do we check? We need a heatsink. Probably it's getting hot very quickly. Let's try. Let's feed the heatsink. And we replace the thermal paste after that and use thermal paste on that Mosfet. It is time after that, but first we have to see if it's working or not. Obviously we have to know if it's working or not. Because keep in mind, you are using a different type of Mosfet, which is not necessarily bad. Usually they are compatible, but can have like different switching time. Can have a different internal resistance. A few things can be different. But I know Apple, they are using high quality components, so we should be fine. Okay, that's okay. Let's plug the screen. Let's check one more time with the power supply. And our Mosfet is not good. Why? I should check from before. Most likely the configuration of the Mosfet is different compared with what we have here. Okay, so we have to find another one. Because yeah, it can be same capsule, but it can have different configuration of the pins. Okay, I took out the Mosfet. Let's try to find another one. Looks like Apple one is not good for us. I'll try to find a gaming motherboard. Oh. Well, not necessary gaming. Not necessary gaming, but a good one. Dual Mosfets. Hmm? That's not a dual Mosfet. Hmm? Dual Mosfets. No, these are single. What we can find? Should be some gaming motherboard around here. I know Samsung has some dual Mosfets. But not this one. Usually if you have a motherboard and you can see a coil with one single Mosfet, that's clearly a dual Mosfet. Nothing yet. Come on, I need a dual Mosfet. Okay, let's see what is with this Apple one and what we are doing wrong here. Why is not working with the Apple one? Let's take this out. And let's try to study the configuration a little bit, yeah? But this is not a dual, but yeah, it is. Yeah, it is a dual MOSFET. It is a dual MOSFET. Now let's see, the gates are on this side. That means the gates has to be on the other side, which is right here. The plus the output is from the middle and it's okay. No, the coil. 1 second. Let me be sure I'm doing the right things here. So the coil is here. That's the coil. What about here? The coil is here. It is here. And that's the plus. Small one, it is a plus. This one. It is a plus, it's not ground. So ground must be here. And that's ground. What's this pin here? What is this? Well, I'm doing something wrong. I am doing something wrong. No, these are not normal dual MOSFETs. Let's have a look online. So what MOSFET is this? ALK190F. Mosfet. Nothing. Nothing online. Okay, let's try 501 501 501 8SG. Yeah, these pop up. Let's have a look together. So I don't get it. 1 second. Let me switch. So that's our MOSFET. Yeah. So that's our MOSFET. And the internal connection. Where is the schematics on the internal connection? Yeah, it's here. This one. So we have one MOSFET. And we have a second MOSFET. So these three pins are all together. And this pin here. Yeah, so we have one gate. But this pin, what this pin is doing, this is from the... Okay, so this has to be plus. Here has to be the coil. Oh, and these two are together. 1 second. So here is the coil, which is right. Okay, here is the coil. Let me see where is the ground. 1 second. Yeah, that's the ground. If this is plus, oh, the ground is not okay. There should be the ground. Was the second pin. This one is from the middle of the MOSFET, which is the coil. Yeah. It's not. Yeah, according with the schematics, the pin number 2 is the same with those 3 pins, yeah? It's the same circuit. Right? gate return. So GR is gate return, this one. So probably this is the feedback which is going to the driver, and it's taking from the middle of the Mosfet, actually from the coil. Let's check for this chip online, yeah. Let me see. I'll check on eBay, because it looks like it's not a usual Mosfet. We can buy this. Copy. eBay. Yes. But only from China. Oh, that's crazy. That's sick. So it's nothing what we can do. The part we can order from only from China. That's the part. 5 pigs, 3 point something pound. And the postage. UK only? Nothing from UK, only from China. Well, I suppose I'll stop this video now. And we have to order the part. I don't think it will work, because clearly the driver is taking the feedback, yeah, from the coil. I don't think it will work, but we can try. The laptop should come on and goes off probably, or it will work. But obviously you can't leave it like that. You have, it's you need power. You need power. But just for testing, just to see the behavior, okay? Just to see the behavior. Just to see the behavior. Only where is the charger? The charger is here. Power on. And nothing, because probably we have to reset the charger. Remember, it was 0 volts last time. Yeah, we have the power on light. And we have picture on the screen. Oh, actually it is working without that Mosfet, which is insane. And it's loading the windows, you can see. But I'll stop this now, because when the processor will ask for power, the power will not be there. Yeah. But the laptop, it is working, which is insane because it's taking feedback. But it's taking the feedback from the coil, and no, actually the feedback is missing because that pin is not connected. But it's working without. That's crazy. So you know what I mean? How can I do it? Yeah, like that. Let me switch. It's insane. I don't understand why this is working. Because you see, this pin is connected here, 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 and here. And here you have the coil. Yeah, this pin 5, 6, 7. You have the coil. So basically, this pin can be straight connected to the board. It's same thing. But because I removed the Mosfet, on this pin is no feedback. It's just an empty pin, and the driver is not getting the feedback, but it's still working. I mean, the way how the laptop works, there should be a power good signal. Power good signal? The driver is sending the signal to the Super I/O and say, look, the power supply is up and running. But not on this case. Not on this case. So it looks like the driver is either ignoring the feedback or is not speaking with the Super I/O. Pretty weird. But at least we know the CPU is good. We've seen picture. We've seen the CPU is good. The graphics is good. So all what is left, yeah, on this is to order that MOSFET. To order the MOSFET and replace the MOSFET. But I know this is this will be working. So I'm sure I can order and I'll fit it and it will work. Okay, so I'll stop this video because we see in the laptop one, the laptop is working. I will order the part, I will replace the part, and obviously it will be working. It's working even now without a MOSFET. And yeah, but it's the waiting time. Probably will be up to 1 month to order the chip from China. But at least you've seen how you can diagnose, how you can, try to figure it out a problem. Oh wait, no, that one is not from CPU. It's from graphics. Yeah, because the graphics chip was getting warm. Yeah. So half of these are for processor and half are for GPU. And most likely these probably are for RAM memory, graphic memory. Okay, but we know, at least we know, we seen picture on the screen. We know the laptop is fine. Nothing else is wrong. Okay, so I'll stop this video now. Thank you for watching. Like and subscribe if you like the video. You see, it's not complicated to diagnose the things. But keep in mind, it's nice to have spare. Like, I don't have any advanced gaming motherboard here. If I will have, probably I will have that Mosfet. Okay? See you on the next one. Bye.